Right now, while you're watching this, the sun is doing something it wasn't supposed to do. Not in 1,000 years, not in 100. Right now, in February of 2026, a flare tore off the surface of our star so violently that it ranked among the strongest ever recorded by modern instruments. And here's the part nobody tells you. The scientists watching didn't see it coming. Not really. Not with the confidence they want you to believe they have. Because for decades, we've told ourselves a comforting story. The sun has a rhythm. 11 years, up and down, like breathing. Predictable, safe. Something we could set our satellites and our power grids and our quiet trust in the sky around. But somewhere in the last few years, that story started to crack. The sun got louder than the models said it would, earlier than the calendars said it should. And now, researchers listening to vibrations from deep inside its core are finding motion nobody had ever detected before. So maybe the question isn't whether the sun is unstable. Maybe it's why we ever believed it wasn't. Let's go back for a second. Not to the flare, to the promise. Because before we can talk about how the sun broke its own rules, you need to understand the rules it was supposed to follow. And they're stranger than you'd think. Every 11 years or so, the sun goes through something like a mood cycle. It starts calm. What scientists call solar minimum. Quiet. Few sunspots. The kind of quiet that feels permanent. The way a sleeping house feels permanent at 3 in the morning. Then slowly it wakes up. Sunspots multiply. Flares start firing off the surface like sparks off a struck match. Coronal mass ejections, great walls of charged plasma, start hurling themselves into space. This is solar maximum. The sun, fully awake, fully loud. And then, just as slowly, it goes quiet again. A new cycle begins. We've been counting these cycles since the 1700s. This one, the one we're living through right now, is cycle 25. In 2019, a panel of the best solar physicists on Earth, backed by NASA and NOAA, sat down and made a prediction. They said cycle 25 would be weak, similar to the one before it, which had already been unusually quiet. Below average, manageable, a sunspot number topping out somewhere around 115. They were wrong. Not wrong in the way a weather forecaster is wrong about Tuesday's rain. Wrong in a way that made them go back and rewrite the forecast mid-cycle. Something that almost never happens. By 2023, the sun was already producing twice the sunspots they'd expected. The peak, originally penciled in for 2025, arrived a full year early. And when it came stronger. Sunspot numbers didn't top out near 115. They pushed past 170. Here's what I want you to sit with for a second. This isn't a star we just discovered. This is the star. The one every civilization that ever looked up has built a myth around. The one we've had spacecraft orbiting since before some of you were born. And we still couldn't tell you with real confidence what it was going to do next. There's something almost humbling in that. Almost embarrassing if you let yourself feel it. We map galaxies 100,000 light years away. We predict the paths of asteroids decades before they arrive. And the closest star, the one 93 million miles from your front door, the one keeping you alive right now, still finds ways to surprise the people who've spent their whole careers trying to understand it. Maybe that's because we've been looking at the wrong part of it. For most of history, solar science has been a surface science. We watch sunspots, we count flares. We track the light and the plasma that reaches out into space because that's what we can see. That's what our telescopes can catch. But the sun isn't a flat disk of fire. It's a sphere, a churning, three-dimensional ocean of superheated, electrically charged gas, stacked hundreds of thousands of kilometers deep, all of it in motion, all of it shaping a magnetic field so massive it reaches past Pluto, and almost all of that motion has been hidden from us. Not because we didn't want to see it, because we couldn't. Think about it like trying to understand a person by only ever watching their face. You can read expressions, you can guess at moods, but you have no idea what's happening underneath. The thoughts, the pressure, the things building quietly before they ever reach the surface. For 200 years, that's basically what solar science has been. Reading a face and guessing at a mind. Which is why, in early 2026, something happened that quietly reordered a lot of what we thought we understood. A team of researchers found a way to listen to the sun. Not metaphorically, literally. Using a technique that tracks tiny vibrations rippling through solar plasma, the way seismologists track vibrations moving through rock during an earthquake, they detected something new. Massive waves, moving in patterns nobody had mapped before, driven by magnetic fields buried deep beneath the visible surface. Waves that had been there, presumably, for the entire time we've been watching the sun from the outside. We just never had the instruments, or the imagination, to hear them. It's a strange thing, discovering that the object you've been studying your whole life has been hiding rooms you didn't know existed. And once you find one hidden room, you start to wonder how many more there are. Here's the thing about hidden rooms. Once you know they're there, you start asking what's inside them. For the sun, the answer is magnetism. Almost everything violent, everything unpredictable, everything that makes the sun instead of just a ball of burning gas. It comes down to magnetic fields, twisting and tangling somewhere deep in its interior, in a process scientists call the solar dynamo. Picture it like this. Deep inside the sun, superheated plasma is constantly rising, falling, rotating. And because that plasma is electrically charged, all that movement generates magnetic fields. Those fields get stretched, wound, and knotted by the sun's rotation, which, strangely, spins faster at the equator than at the poles. Over time, the tangle gets so tight, so strained that it has to release. Somewhere, a knot snaps to the surface. And when it does, you get a sunspot, a flare, a wall of plasma blasted into space at 1,000,000 miles an hour. The dynamo is the engine. Everything we see, the light show, the storms, the auroras painting the sky green over cities that never normally see them, is just the exhaust. And until recently, we'd never actually watched the engine run. That changed with the discovery of those deep magnetic waves. What researchers are calling large-scale Rossby-type waves, moving through the sun's interior in patterns shaped by its inner magnetism. It sounds technical, and it is. But strip away the vocabulary, and what's left is something almost unsettling in its simplicity. The sun has a pulse we never knew about, a rhythm underneath the rhythm. And that hidden rhythm may be quietly rewriting the ones we thought we understood. Because here's what's strange. Solar Cycle 25 wasn't supposed to be strong. The models, built on decades of surface observation, said weak, quiet, below average. And yet it arrived early, peaked high, and kept producing flares that punched well past what forecasters expected. If the real engine driving the sun's behavior has been running somewhere we couldn't see, then maybe we haven't been forecasting the sun at all. Maybe we've just been reading its shadow and calling the shadow a prediction. There's a strange kind of intimacy in that thought. We talk about the sun like we know it. We've named it cycles. We've built machines that stare at it every second of every day. And it turns out, this whole time, it's had depths we never reached. A person you've loved for years can still surprise you. Not because they changed, but because you never saw the whole of them to begin with. Maybe stars aren't so different. Maybe nothing that large, that old, that alive with motion, ever fully hands itself over to be known. Which brings us to the part that isn't just poetic, the part that actually matters for the ground you're standing on right now. In May of 2026, a team studying nearly 50 years of solar data proposed something that should probably concern you more than it does. They weren't just looking at ordinary flares. They were looking for the rare, extreme ones, what physicists call S-class events, eruptions so powerful they measure more than 10 times the intensity of an already major flare. The kind capable of knocking out satellites, disrupting power grids across entire regions, threatening astronauts who have nowhere to hide from what's coming, using machine learning to comb through decades of solar behavior. They identified specific windows, stretches of time within this very cycle, when the risk of one of these superflares spikes dramatically. One window they found stretched from the middle of 2025 into the middle of 2026. We are, as you're hearing this, standing inside a window scientists have flagged as elevated risk for the most dangerous kind of eruption our star is capable of producing. Not a certainty. Nobody is saying doom is scheduled for a Tuesday afternoon, but a window. A door standing open and no one entirely sure what's going to walk through it. And that, maybe, is the real unraveling of the story we grew up with. We wanted the sun to be a metronome. Dependable, distant, indifferent in the safest possible way. Instead, it looks more like something alive. Something with moods we're only beginning to learn how to read, using instruments we only just built, listening to a language we only just discovered it was speaking. We are, in every sense that matters, still learning to listen. Let's talk about what danger actually means here, because it's easy to hear the word superflare and picture something abstract, a headline, a statistic, a thing that happens to other people's satellites. So let's make it real. In 1859, the sun let go of a flare so powerful it's still the benchmark scientists use today. The Carrington event, telegraph systems across Europe and North America, the entire cutting edge of human communication at the time, sparked, failed, and in some cases caught fire. Operators reported their machines working even when disconnected from batteries, powered directly by currents induced in the wires by the storm overhead. Auroras, usually a polar phenomenon, lit up the sky as far south as the Caribbean. People in Cuba stepped outside at midnight and saw a sky bright enough to read by. That was 1859. A world lit by gas lamps and telegraph wire. Now, picture that same storm arriving today. Not telegraph wires. The entire electrical grid a modern country runs on. Not a handful of ships navigating by compass. Thousands of satellites carrying GPS, banking systems, communication networks, weather tracking, military infrastructure. Study after study has estimated that a Carrington-level event striking Earth today could cause damages in the trillions and take not days, but months, possibly years, to fully recover from in the hardest-hit regions. It hasn't happened again. Not at that scale, not yet. But in May of 2024, during what researchers were using as a case study for building their new forecasting models, spacecraft caught something extraordinary happening on the far side of the sun. The side permanently turned away from Earth. Enormous flares, estimated at intensities far beyond anything that struck us in recorded history. We were never in the blast path. This time. That's the sentence that should sit with you. This time. Because the sun doesn't choose where it points its worst moments based on what's convenient for us. It doesn't know we're here. It doesn't know our satellites, our grids, our fragile dependence on things staying online. It simply builds pressure deep in that magnetic engine we only just learned existed and releases it wherever the geometry happens to land. And this is where the story gets stranger still. In the earlier part of 2026, scientists studying auroras above Japan noticed something nobody expected. towering red auroras, reaching to altitudes far higher than typical auroral displays, appearing even during storms that were, on paper, only moderately strong, which suggests something quietly important. The sun may be doing more, even during its calmer moments, than our current instruments are built to notice. The storms we can measure might only be the ones loud enough to leave fingerprints we know how to read. There's even research, still early, still speculative, the kind of finding that makes other scientists raise an eyebrow before they raise a hand to challenge it, suggesting a possible link between solar storms and earthquakes. The theory goes like this. When a solar storm disturbs Earth's ionosphere, it can generate electric fields that reach down into the crust itself. If a fault line is already under stress, sitting right at the edge of slipping, that added electrical pressure might be enough to tip it over. Nobody's claiming the sun causes earthquakes. What they're asking is quieter, and in some ways more disturbing. Whether a star 93 million miles away might, in rare moments, reach further into our world than we ever imagined a star could reach. I don't tell you this to frighten you. I tell you this because I think we've gotten used to a very particular kind of quiet. The quiet of things we've decided not to think about because thinking about them feels too big. We go about our days assuming the ground holds still, assuming the power stays on, assuming the sky above us is simply background, decoration. We rarely ask what it's actually doing up there, moment to moment, or what it's capable of when it stops behaving the way we've trained ourselves to expect. Maybe that's not naivety. Maybe it's just what living requires. You can't stare at the potential for chaos every single day and still function, still make breakfast, still fall asleep at a reasonable hour. But every so often it's worth remembering. The world you build your life on top of is not as stable as it feels. Not the ground, not the grid, not even the star that made the ground and the grid possible in the first place. We call it a sunny day, as if that word, sunny, were the whole story. So if the sun isn't the steady metronome we imagined, what is it really? Maybe the better comparison isn't a clock. Maybe it's an ocean. Think about how we talk about the sea. Calm on the surface most days. Predictable enough that we build cities along its edge, plan our lives around its tides, trusted enough to put our children in small boats and send them out to play. And yet, underneath that calm, there's always motion, always pressure. Currents dragging in directions we can't see from the shore. And every so often, not often enough to live in fear of it, but often enough that it's written into every coastal town's collective memory, the ocean reminds everyone watching that calm was never the same thing as safe. The sun might be the same kind of thing. A vast, churning body that spends most of its life behaving well enough that we stop noticing it's alive at all. And that's really the heart of what's happening in solar science right now. Not that the sun suddenly became unstable in 2024 or 2026 or any single dramatic year you could put a pin in. It's that we're only now developing the tools to notice how unstable it's always been. For most of human history, we watched the sun with our eyes, and later with early telescopes, and we built our entire understanding around what those instruments could catch. Sunspots, the general glow of activity. It's a little like trying to understand a storm system by only ever looking at satellite photos of clouds, useful, but nowhere close to knowing what's happening in the pressure systems underneath, the temperature gradients, the invisible physics actually steering the weather. The magnetic waves discovered in early 2026 changed that equation. For the first time, researchers had a way to trace motion happening far beneath the surface, not by watching light, but by watching vibration. The same way doctors listen to a heartbeat instead of trying to guess it from the outside. And what they found wasn't chaos exactly. It was structure, pattern, a rhythm nobody had mapped, moving through the sun's interior, shaped by magnetic forces we're only beginning to understand. Here's what strikes me most about that. We spent centuries assuming the sun's unpredictability was randomness. One told that when a cycle came in stronger or earlier than forecast, it was simply the universe shrugging, refusing to be pinned down. But structure isn't randomness. Structure means there are rules. It means the sun isn't ignoring physics. It means we hadn't yet learned the physics it was following. That distinction matters more than it might sound like it does. A universe governed by rules we haven't discovered yet is a very different universe than one governed by no rules at all. One is frightening in a way that closes a door. Nothing to learn, nothing to prepare for, just chaos to endure. The other is frightening in the way that opens a door. Difficult, humbling, but not hopeless. A puzzle instead of a wall. I think that's part of why this story has stayed with me the way it has. Because it isn't really about the sun refusing to behave. It's about how much confidence we can quietly, mistakenly build around models, scientific or otherwise, before reality reminds us those models were only ever approximations. Best guesses, dressed up to look like certainty. We do this everywhere, not just in solar physics. We build our sense of safety on patterns we've noticed holding steady for a while, and we start treating those patterns like laws. The job that's always been stable, the relationship that's always felt solid, the body that's always done what we asked of it. And then something shifts. Earlier than expected, stronger than expected, and we're left standing in the wreckage of a prediction we never realized we'd been quietly, completely relying on. Maybe that's the real reason a story about sunspots and solar dynamos can sit heavier on you than it should. It's not really about the sun. It's about the recognition, somewhere underneath the facts, that the things we count on to hold still rarely promise us that they will. The sun doesn't owe us its calm. It never did. It's been erupting, twisting, releasing pressure from a hidden engine for 4.5 billion years, long before anything on this planet existed to be inconvenienced by it. We are, in the truest sense, guests standing very close to something enormous and indifferent, and we've simply been lucky, so far, that its worst moments have mostly missed us. That's not a comforting thought, but I don't think comfort was ever really the point of understanding something true. So where does that leave us? Standing under a star we're only beginning to actually understand, in a moment when its behavior has already broken more than one prediction. I think the honest answer is paying closer attention than we used to. Because here's something worth knowing. The scientists tracking all of this aren't panicking. If anything, the tone coming out of solar physics right now is closer to fascination than fear. There's a kind of quiet excitement in the research. The sense of a door swinging open onto a room nobody had mapped before. When those magnetic waves were discovered inside the sun earlier this year, the researchers behind it didn't describe it as alarming. They described it as a new way to listen. A new set of eyes turned toward a place that had always been hidden. That's not the language of people bracing for disaster. That's the language of people who just realized the puzzle is bigger and more solvable than they thought. That distinction matters because it changes what this story is actually about. It's not really about the sun turning against us. Stars don't have intentions. They don't build up pressure with any awareness of what sits 93 million miles away, waiting to be affected. The sun isn't unstable in the way a person having a bad year is unstable. It's simply finally being seen more clearly than it's ever been seen before. And clarity, it turns out, often looks like instability at first, simply because we're noticing details that were always there, just previously invisible to us. Think about how strange that is when you sit with it. The sun hasn't changed its fundamental behavior in any meaningful way across the entire span of human civilization. What's changed is us. Our instruments, our models, our willingness to build spacecraft that can survive close enough for long enough to actually listen. The chaos isn't new. Our awareness of it is. And that reframes the fear a little, doesn't it? Because it's one thing to be afraid of a threat that's escalating. It's another thing entirely to realize you're only now developing the senses required to notice a threat that was quietly present the whole time. One of those is genuinely getting worse. The other is simply the discomfort of finally opening your eyes in a room you'd been sitting in unaware for years. I think most of us live a version of that discomfort in smaller, quieter ways all the time. We go a long stretch not noticing something. A pattern in a relationship, a signal from our body, a slow shift in a situation we've told ourselves is fine. And then, one day, something forces our attention onto it, and it feels like the thing itself has suddenly become dangerous. Usually, though, the danger or the truth was already there. What changed was that we finally had to look. That's not a small distinction. It's the difference between panic and preparation. Panic says, everything I trusted is falling apart, and there's nothing to do but brace for impact. Preparation says, I finally have enough information to actually plan, to build resilience, to stop mistaking ignorance for safety. The scientists chasing these superflare risk windows, mapping the sun's hidden interior, tracking auroras reaching further than expected into the upper atmosphere. They're not doing this because they've given up on predicting the sun. They're doing it because, for the first time in centuries of trying, they finally have the tools to get closer to actually succeeding. There's something quietly hopeful buried in that, even inside a story this unsettling. We are right now living through the exact moment our species is learning to read a language we've been surrounded by since before we had a name for the sky. The sun has been speaking in flares and flickers and hidden magnetic tides for 4.5 billion years. We only just built the ears. And once you've built the ears, you don't unhear what's coming through them. You just start listening differently to everything else too, which is maybe the most human thing about this entire story. Not that the sun turned out to be less predictable than we hoped, but that the moment we discovered that, we didn't look away. We built better instruments. We asked better questions. We kept listening, even once the answers stopped being comfortable. If you're still here with me, this far into the story, still listening while I talk about waves inside a star 93 million miles away, I want to say something, quickly, before we keep going. This channel exists for exactly this. For the kind of curiosity that doesn't stop at the easy answer. If that's the kind of person you are, consider subscribing and come back tomorrow, because there's always another thread like this one waiting to be pulled. And while I have you, I'm curious. When you found out the sun wasn't as predictable as you assumed, did it unsettle you? Or did some part of you find it strangely comforting? Tell me in the comments. I read everyone. Okay, back to it. Because there's one more layer to this story, and it might be the strangest one yet. All of this, the hidden waves, the early peaks, the superflare risk windows, it isn't just about understanding our own star better. It's about understanding what normal even means for a star at all. And that question reaches a lot further than our solar system. For most of the 20th century, our entire idea of a stable star came from one data point, the sun. We assumed reasonably that other stars like it, similarly sized, similarly aged, sitting in that comfortable middle stretch of their lives, probably behaved in roughly the same way. Calm, with occasional flares, a gentle rhythm. Then, in recent years, astronomers started pointing better instruments at younger, smaller stars. The red dwarfs, the M-type stars that make up the vast majority of stars in our galaxy. And what they found was startling. Around some of these stars, researchers detected enormous rings of plasma, swirling storms far more violent proportionally than anything our own sun produces. Space weather so extreme it makes our worst solar storms look almost gentle by comparison. Dips and flickers in starlight that, once decoded, revealed entire storm systems orbiting stars that, from Earth, just look like small quiet points of light. Which raises an uncomfortable question. If red dwarfs, smaller, cooler, seemingly calmer stars, can host storm systems that violent, how confident should we really be that our own sun has permanently outgrown that kind of extremity? Stars evolve. Their magnetic behavior shifts across the billions of years of their lives, sometimes in ways we're still mapping for the very first time. The sun we know today isn't necessarily the sun that existed a billion years ago, and it isn't necessarily the sun that will exist a billion years from now. We like to think of the present moment as the default, as if the sun we were born under is simply how the sun is. Full stop, permanently, the way it's always been and always will be. But 4.5 billion years is a long story, and we've only been watching closely for a few centuries of it. That's not even a paragraph in a book this long. It's barely a comma. Maybe that's the quiet vertigo sitting underneath everything we've talked about today. Not just that the sun surprised us, but that the version of the sun we grew up trusting, steady, familiar, background noise to our entire existence, was never guaranteed to stay that way. It was simply the chapter we happened to be born into. There's a strange kind of humility that comes with really sitting with that. We spend so much of our lives assuming the big things, the sun, the ground, the shape of the sky, are fixed points, constants we can build everything else on top of. And in the scale of a single human life, they mostly are. Stable enough, steady enough to raise children under, to build cities beneath, to fall asleep trusting that morning will arrive the same way it did yesterday. But zoom out even slightly, and none of it was ever promised. Not the calm cycles, not the quiet flares, not even the sun's basic temperament across the eons. We are living inside a moment, a good moment, mostly a livable one. Inside a much longer, much wilder story that started long before us and will keep unfolding long after. I don't think that should frighten you as much as it should focus you. Because if the ground beneath your certainty is more provisional than you thought, then paying attention, really paying attention, the way these scientists are finally learning to listen to a star we assumed we already understood, stops being optional. It becomes the whole point. So let's go back to where we started. To that flare in February, tearing off the surface of a star we've been watching for centuries. We called it unpredicted, and it was by the models, by the panels, by the decades of careful, patient science that came before it. But maybe unpredicted isn't the same as unknowable. Maybe it just means we were still early in the listening, because that's really what this whole hour has been. Not a story about a star losing control. A story about us slowly, imperfectly, learning to hear something that had been speaking the entire time. Through sunspots we misread, cycles we underestimated, waves buried so deep we needed new instruments just to know they existed at all. The sun didn't change to surprise us. It was always this alive, this restless, this much bigger than the calm little disk we learned to draw in school. We just hadn't caught up to it yet. And maybe that's true of more than the sun. Maybe most of what we call stable is really just the parts we've had time to understand. The rest, the deeper waves, the hidden currents, the pressure building somewhere underneath the surface of anything vast enough to hold secrets. That's not instability. That's just what hasn't been listened to closely enough. Not yet. You're standing on a planet circling a star that has been quietly rewriting itself for 4.5 billion years. And for one small, remarkable stretch of that story, you got to be here, watching, wondering, asking better questions than the ones you were handed. That's not nothing. If this pulled something loose in you, subscribe and follow this channel. If it changed the way you'll look at the sky tonight, even a little, share it with 5 people who'd feel the same thing. And before you go, leave a comment, not the easy kind. Tell me something true, something that actually crossed your mind while you were listening. And tell me what you want me to go looking for next. There's always another hidden room. I'll see you there.